Okay, let's begin our review for similar shapes. Similar figures have blank size and blank shape. So this should be a different size and the same shape. B, give a similarity statement for the shapes below. So we have an ABCD trapezoid and EFG. So right now it says fill in. We're going to give a similarity statement first. So if we look for our corresponding sides and angles, we would see that A corresponds with E. So we would say the trapezoid A, and let's go ahead and write trapezoid E. We'll put our similar symbol in there. And we know that B and F, so B would be the next letter, F would be the next letter. C and G corresponds, so that would be C, this would be G, and then we have D corresponding to H. So trapezoid ABCD is similar to trapezoid EFGH. There's your similarity statement. Letter A down here, it says fill in the blanks to complete the proportional statement. So segment AB here would correspond to EF. So EF should go down here. We could also go back to our similarity statement here, and we see that AB corresponds to EF. Our next one here, FG, if we look at the picture, FG is here, so that would correspond to BC. And again, we could look back at the statement, FG goes with BC. AD here, we'll name that side 3, would correspond to EH, and then we have HG, so H going to G would be D, and then C. So those are your proportional statements for corresponding sides. All right, next slide. Slide 2. It says, which triangle is similar to triangle XYZ? So first, we'll go ahead and identify corresponding sides first. So here we have a little right angle, so let's name that side 1 and side 2. The right angle here, so this would be side 1, side 2. Your right angle, side 1, side 2, and side 1 and side 2. So let's go ahead. What we're looking for is a ratio that's going to be equal or equivalent in these statements. So in triangle, we'll call this triangle A, B, C, and D. So for triangle A, we have side 1 over side 2. So this would be 30 over 24. Well, that ratio reduces. If we divide by 6, that would be the same as 5 over 4. The next triangle, our side 1 and side 2, would be 32 over 26. And if we divide by 2, that's going to reduce to 16 over 13. Is 16 over 13 equivalent to 5/4? No. Now our next one, side 1 would be 35 over 28. We can reduce this by dividing by 7, and that would be equal to 5/4. And is 5/4 equivalent to 5/4 in the first one? So that would be a yes, that is similar. In our last triangle here, D, 10 over 14, and if we reduce that dividing by 2, we end up with 5/7. 5/7 is not equivalent to 5/4, so that would have been no. So the third triangle was similar to triangle XYZ. All right, letter B. What sides on the similar triangles correspond to XY? So let's go back up here. So XY was side 2. So on the similar triangle, side FG corresponded there. All right, letter C. If the measure of angle X is 85 degrees, the measure of Y is 55, and the measure of Z was 40 degrees, find the measure of the angles of the similar figure. So let's just redraw our first one down here, this was z, x, and y. And it said that x was 85, y was 55, and z was 40. Our similar triangle had h, f, and g for your corresponding points. So remember, similar figures have congruent angles. That means they have the same measures. So if angle x corresponds to angle f, f had to be 55 degrees. Angle z was 40 degrees, so that means angle h was 40 degrees. If angle y was 55 degrees, g was also 55 degrees. So those would be your corresponding angle measurements. All right, we're on slide 3. So it says here triangle ZYW is similar to triangle CBA. Find the length of ZY. So ZY is here. So let's go ahead and name that side 1. The corresponding side over here would be here. And then we can, as long as we have a corresponding side where they both have the measures, we can find x. We'll go ahead and use this corresponding side. We're going to name that triangle A and B. So let's go ahead and set up our proportion. So let's do side 1 over side 2. Triangle A compared to B. So in A, side 1 is x, and side 2 is 2. Triangle B, side 1, the corresponding side was 7, and then we have 4. So using our cross products, 4x equals 2 times 7, 4x equals 14, and when we divide both sides by 4, we're going to get x equals 3.5 inches. All right, next one, A. It says figure ABCD is similar to figure EFGH. Find the length of GH. So that would be this side down here. So let's designate that as side 1. Corresponding side would be the 5, and our side 2 would then be the longer sides. And since these are rectangles, opposite sides are congruent. So it doesn't matter which side we name 2 or 3 as far as their measurements. We'll call this rectangle A and rectangle B. So let's set up our side 1 over side 2, our A and B. So in rectangle A, side 1 is 5, side 2 is 8. In B, side 1 is our x, and side 2 is 4. So using our cross products, we would do 8 times x equals 25 times 4 is 20. Divide both sides by 8, and x is going to be equal to 2.5 centimeters. All right, moving along. Okay. Slide number 4 says given triangle IJK is similar to triangle LMN, find the length of IJ right here, and then the length of IK here, Y. All right, so let's identify our corresponding sides. Now, IJ we designated as side 1. So IJ corresponds to LM over here. So LM is side 1. We designated IK as side 2. So if I have IK as side 2, that means LN also is side 2. So there's your side 2. And that leaves us with the corresponding side 3, the 54 and the 42. So let's go ahead and find the first one here. We'll name this A and triangle B. So in order to find x, the only measure we have over here is 54. So we're going to have to use side 1 and side 3 to find the measure. So let's do our A and our B. We need side 1 and side 3. And so this would be x. Side 3 is 54. Side 1 in B is 28. And side 3 is 42. So when we write our cross products, we have 42x equals 54 times 28. And 42x equals 1,512. We're going to divide both sides by 42. So x is going to be equal to 36. So we know that x here is 36. To find y, now we could use side 1 or side 2. But we'll go ahead and let's use side 3 again. So we need side 2 and side 3. And we have an A or a B. So side 2 in A is your y. Side 3 is 54. Side 2 in B is 35. And side 3 is 42. And so we would have 42y equals 35 times 54. And 35 times 54 comes out to 1,890. And then we divide both sides by 42. And y would be equal to 45. All right. Letter B says, given quadrilateral PQRS similar to TUVW, write a proportion to find the length of segment PS. So if this is PS, the corresponding side would be TW. So PS corresponds to TW. And we have a 35 down here, and this is segment SR. So if we're looking at SR, we'd be looking for WV. So WV would be side 2, and this would be side 2. So there are other proportions you could write, but this, let's go ahead and use this one. So if we did A and B, and we could do side 1 over side 2. And so this would be A side 1 would be X. B side 1 would be 15. A side 2 would be 35. And B side 2 would be 25. So your cross products would be 25x equals 15 times 35. So no matter how you set this up, you could be using different sides. This is what you have to end up with once you cross multiply your two proportions. Okay? And we're going to call that the review number 1, and review for slide 5 and 6 will be in the next video.